In this video, we're going to take our understanding of x-intercepts and y-intercepts just a bit further. So far, what we've seen with x-intercepts and y-intercepts is that the x-intercept is where the graph crosses the x-axis. Similarly, the y-intercept is where the graph crosses the y-axis. The other thing we saw with these is that when you have an x-intercept, that means it's on the x-axis, which forces the y value to be 0. So the y value of all x-intercepts will be 0. Similarly, using the same logic, if a point's on the y-axis, that's going to force the x value of that ordered pair to be 0. So the x value of all y-intercepts will be 0. We're going to use these 2 points, this idea, in order to determine the x-intercepts and the y-intercepts when we're given a function. Let's look at an example so you can see what I mean. Determine the x-intercept and the y-intercept of the equation 2x minus 3y equal to 6. Now, if you want to, usually with relations and functions, we have them solve for y. If you want to solve this for y to start with, you can, but you don't need to in order to determine the x-intercept and the y-intercept. We just need to use the idea that for the x-intercept, the y value is always going to be 0. So we start to look for the x-intercept by letting the y value equal 0. What I mean by that is we're going to take our equation, and where we see the y, we're going to substitute in a 0. And if that equals to 0, then the corresponding x will be the x value of an ordered pair that's on the x-axis. So once we solve this down, we get 2x equal to 6. So x equals to 3, which tells me that my x-intercept is the ordered pair 3, 0. The 0 is the y for 0 that I started with, and the 3 is the x value that I ended up finding for this ordered pair. So that's the x-intercept. Now for the y-intercept, we're going to let the x equal 0. When I plug that in, instead of substituting out the y this time, I will substitute out the x. And then I have my minus 3y equal to 6. In this case, now I'm solving for y. Well, 2 times 0 is 0, so that part goes away. So I get a negative 3y equal to 6. So y equals to negative 2. What that means is my y-intercept is going to equal the ordered pair negative 2, comma, oh, I'm doing that backwards, 0, comma, negative 2, because we always put the x first. Our x, the 0 for x, is coming from where we started, and the negative 2 for y is the one that I ended up solving for. Alright, let's do another example. Alright, let's do finding the x and y intercept for the function f of x equals the square root of x plus 4. For the x-intercept with these function ones is always going to be the more complicated one. But we're going to let y equal to 0. And for the y-intercept, we're going to let x equal to 0. Now, in order to understand this in terms of x and y, we have to remember that the function notation f of x, that represents our output. So I can switch that out entirely and say y equals the square root of x plus 4. So to say let y equal to 0 is the same thing as to say let f of x equal to 0. Now I'm going to start with the y-intercept because that one always is a little bit more straightforward. And the reason why is because the function is solved for y, and so we're not going to have to solve for y. We just need to plug a 0 in for x here. Well, so that's going to give us y equals the square root of 4. So y equals 2. Now, they're not always going to work out nicely like this, but sometimes they do. So what that means is that my y-intercept is the order pair 0, 2. Alright, now let's go back to the x-intercept. It's not that bad, but it is a little bit more complicated. So we're going to have 0 equals the square root of x plus 4. The reason why finding the x-intercept is more complicated with functions is because it's not solved for x, so now we have to solve it for x. This is a square root equation, so the way we solve for x is to square both sides to cancel out the square root. 0 squared is just 0, so this is 0 equals x plus 4. Then I need to subtract 4 from both sides, so I get x equals a negative 4. What that means is my x-intercept equals to a negative 4, the order pair negative 4, 0. And there you have it. Now on some of these with you know, we've talked about the graph of a square root function, and you know, it looks like that if it shoots off to the left, but let's say if you have the graph of a parabola and your axes go like this, it's possible to get more than one x-intercept. Okay, so if that's how the math is working out, don't think you've done something wrong. It is possible. But the general idea is to take the function you're given, for the x-intercept, let y equal 0, and solve the resulting equation using the solving techniques that we've worked on. For the y-intercept, let x be equal to 0 and use the techniques that we've worked on with their different equations to solve for that y. And then you express that as an order pair. Go ahead and give some of these a try and see how you fare.